Hello everyone, so welcome back to my YouTube channel. In today's video, we are going to solve today's problem of the day, that is uh, 3689 maximum total subarray value of 1. It's a medium mark problem on lead code, but I can assure that this question is not of a medium level. It's a very easy problem. Okay, first let us understand what does this question says about. We are given an integer array of nums of length and an integer k. So we will be given some L and R. It means that we will be given some range. We have to find some range, exactly same subarray of length and of length left and sorry, not length, of some range L and R that can be chosen more than once. We can choose this subarray more than once, and we have to find the total value as a sum of the values of all chosen subarrays. We have to return the maximum possible total value we can achieve from this question. Okay, so if we are given as k equal to 2, this tells us that how many times we can take the number. So if it says this, how many times we can take the number. So if I have taken the length of 1 and range of 2, sorry, not length, left index as 1 and right index as 2. So the maximum, the element is 3 and the minimum is 1. So we have to maximize the difference between the maximum and minimum value of the subarray that we are going to choose between L and R. So from these we can find that is 2, and how many times we can choose it. We can choose 2 times. So it's better. It's a greedy. Let us go through by a greedy approach. If we are going to follow this greedy approach, what should be our mindset, that how we are going to tackle this. So if we are thinking of a greedy solution, so I will find some subarray in which I can get a minimum and a maximum of the element, and due to which the difference of both of them should be the maximum, and I will multiply it with our k. So let us look at the constraint. Constraint is 5 into 10 raised to the power 4. So we cannot go for big of n square because it will be 25 into 10 raised to the power 10 raised to the power 8. So it will be around 2.5 into 10 raised to the power 9, which will be greater than 10 raised to the power 8, and which will give us TLE. So we can only write a better solution for this problem is big of n approach. So we have to think of a solution which can solve this problem in big of n approach. So okay, so let us take this example. In this example, we are given, so what we are going to choose for k equal to 3. So I will choose for the maximum is 5 and the minimum is 1. So even if I choose this 2, if my L is equal to 0, 1, 2 and R is 3, if I chooses these two elements, then the difference will be 4 only, and the multiplication of 4 k into times. So I will choose this maximum seven is k times. So it will eventually maximize my output. So it will be 4 plus 4 plus 12. So what is the solution of this problem? How can approach this problem? So the basic approach to solve this problem is that we will find the maxima and we will find the minimum. After finding the maxima and minima of of a subarray, we can find the maximum difference between the maxima and minima. That will be, and then we will multiply it with the k. So it's an easy problem. But I don't know why it is marked medium on this lead code, because the main reason is it is marked medium because the next subsequent follow up of this problem is 3691, which will ask us in which we are going to be in this problem we can choose same subarray many times, but at that problem we cannot choose the same subarray many times. So this is the only difference, and that question can only be solved by the concept of the segment tree. That's why this problem is marked medium on the lead code. So let us check out what how can we solve this problem. First of all, I will initialize my maxi with minimum and minimum with maximum. So this loop will eventually find me the maxima of my subarray and the minimum of my subarray. After finding the maxima and minima of the my sum array, I will just find the difference between the maxima and minima, and I will multiply it with k. And I will return this answer as long because it is asking for that. So long answer, I will then return my answer. So this solution is a big of n solution which will be easily accepted on the lead code. So let us run this problem on lead code. Yeah, you can see that we have passed the test cases. So let me submit this problem. Let me submit this problem. Yeah, it was submitted. Thank you.